Good morning, scientists. Welcome to science class today. It is Thursday, April 16th, and today we are going to be doing a Zoom later, and we are going to be thinking about the inside of the Earth. What is the inside of the Earth? What's the composition of the Earth? Composition is just a fancy word for saying what something is made of. And that's kind of what we're going to deal with here today. And some things we've done this week. And so that's what we're doing here. So remember, Zoom meeting at 4 today. We're going to go over the things that are going to be on the Quizlet Live that we're going to do as well. All right, so what is inside the Earth? So this is a cross-section of the Earth. It's kind of like a piece of pie taken up. So the Earth has lots of different layers, and we're going to go over a few of these in your crates. The first one, starting from the outside part of the Earth towards the inside, is going to be the crust. All right, it's rigid. It's the outer layer. It's what we're standing on. All right, think of it in that way. All right, as well. And that crust is just this black section here. You can see is just hard. All right, and then you have ocean crust and then continental crust. We'll talk about those in a little bit. All right, our next one is the upper mantle. Right, the upper mantle. So now we're in this part. This will be the red into the pink. All right, you have the upper mantle and the lower mantle, but this is referred to as the mantle. All right, so we're getting further, deeper into the Earth. The upper mantle is rigid and slightly melted, kind of like a thick ooze of melted rock is the best way to look at it. If you put it in a cup and you poured it, it wouldn't really pour, at least not very well. Think of something like honey, or like a really thick syrup or something like that. As we go further down, we're going to get to the lower mantle. Into the lower mantle, we're starting to get more solid pieces in here. As we move further down, we get into the outer core. Outer core is solid. The outer core is liquid. This is warmer temperatures. It is completely liquid. It's melted molten rock, which is just rock that is been completely melted. All right, that gets us down to the outer core, which is here. Another part we're talking here. All right, and then gets us down to the inner core. The inner core is the denser part. It's mostly a lot more iron than we see other places. It is solid, although it is much warmer. The reason it's solid is because even though it's got a lot of more thermal energy, which makes those molecules shake more and take up more space, we have all of this rock pushing and gravity pushing down in it. So it's still hot enough to be liquid, but it's been smashed down so much, right, that it's actually a solid form. And this is the basic composition of what's the inside of the Earth. All right, so now we're looking at it a little closer. Look at just the upper mantle and the crust. All right, so the crust is this top part, and then right below it is the very top end of the upper mantle. This is all solid rock. We call this the lithosphere. That's going to be one of the words we're going to talk about. It's the uppermost layer where the crust is, includes the upper mantle. Right, it is broken into these different pieces that move around the Earth. So there's the North American plate. There is the Eurasian plate, the African plate, so there's, I don't know, about 20 or so different plates, and those plates are moving around the world. They create volcanoes, they create earthquakes, they create our land masses as well. They've changed where things are on Earth. We haven't talked about Pangea yet, but if you look at the globe, you'll notice that some of the pieces, like for instance, South America, if you think about the edge of South America, it kind of puzzle pieces into Africa. And that's because the South American plate and the African plate are slowly pushing away from each other. Anyway, so the point here is the lithosphere is broken in these pieces. These are big hunks here. All right, now crust. We have two types of crust. We have continental crust and ocean crust. Continental crust is made of granite. That's why we find granite everywhere. Very, very common rock. We have can be lightly colored, like we talked about. We're doing rocks and minerals, but continental crust is all made of there. Where basalt, this dark, heavy rock, basalt is what the ocean crust is made of right here. And if you notice here, you see how this ocean crust goes underneath. All right, if these two plates, if this was a plate here and this is a plate here, and they both were coming together, the ocean crust is always going to dive underneath, always going to push underneath, and you're going to get mountain formation when that happens because of all the pressure. It's kind of like two cars smashing together and their front ends kind of buckle up. Basalt is more dense than granite, and that's why it always will dive in there. All right, but lithosphere broken into pieces. We call those plates. The crust is the very top. This is all rigid, all right? And then granite makes up the continental crust, where basalt makes up the ocean crust. All right, so seismic waves. All right, so these are energy waves that move through the earth after a earthquake. An earthquake is just any kind of movement shifting inside the earth. And this is a lot of reason how we know what's inside the earth, because we have not even gotten through the crust digging wise. Not even close. So what these are showing is energy waves moving, and we can detect them throughout the earth. And so if there is an earthquake, we can tell exactly where it is, where it happened there, and how deep in the earth it happened because of the waves. So we know what was the energy level at this wave at this point, this point, this point, this point. We can then use math to calculate where it is, and we know how thick these layers are and what they're made out of because of how these waves move. Because these energy waves are going to move in straight lines, but when they go through something different, they're going to turn. So this is how we know one of the reasons we know the core, outer core, and mantle are made of, because those waves will turn and let us see things. So just seismic waves are just vibrations that travel through the earth, carrying energy from an earthquake. There, so that's what a seismic waves are. All right, so that's the basics of what the inside of the earth is made of. Okay, one thing I forgot to talk about was the asthenosphere. The asthenosphere is in the upper mantle, and it's this plastic in that it's very moldy. It's that upper mantle I was talking about before. The asthenosphere is where convection currents are going to happen. And so you got this hard rock on this gooey rock, I guess the best way to say it. And then you have below it even more liquid rock. And this is where convection currents happen. If you remember from last year from weather, we talked about convection currents. Convection currents also happen inside the earth as well. All right, so just a quick review. All right, these are the words we're going to be dealing with. All right, so basalt makes up the continental crust or the ocean crust. We have the inner core, all right, which is very center of the earth, right? Very dense. Outer core, molten iron and nickel. So this is going to be melted. The lithosphere was the very top layer. That's this like hard rock. Granite makes up the continental crust. Pressure is this force exerted on something. Pressure is what causes earthquakes and causes all the movement inside the earth. And then the mantle is closer to the crust. It's hot, but it's still technically solid. The crust is the outside, and the rock forms on the outside. The asthenosphere is the soft layer mantle that the lithosphere floats on. The plates float on, and seismic waves are energy that moves through. So this is the quiz that we're going to be dealing with later today at 4:00. All right, as well. So if you have questions or comments, bring them to the Zoom, or you can post it on Google Classroom as well. I will see you guys later, and hopefully see you at the Zoom at 4:00.